let's look at a very specific example out of your book. Let's look at example 8. And the example reads, a retailer sells two types of coffee beans. One type costs $9 per pound and the other type costs $7 per pound. Find all the possible amounts of the two different coffee beans that can be mixed together to get a quantity of coffee beans costing $8.50 or less. So this question is asking us to mix a couple different kinds of coffee together and come up with a blend that's going to cost $8.50 or less. So we know that because of this statement at the end, $8.50 or less, that we're going to deal with an inequality. And there are multiple solutions or multiple mixtures that we can create that will have a cost of $8.50 or less. So we're going to want to represent our solution graphically. So let's write our inequality to begin with. And before we can write the inequality, we need to define some variables. So just for ease, I'm going to let x be the amount, spelled correctly, of $9 coffee beans I'm buying. And I'm going to let y be the amount of $7 coffee beans. So my inequality is going to look like this. I'm going to have my x coffee beans plus my y coffee beans. And the only information I know is that the cost is going to be less than or equal to $8.50. Since my result is a price, I need to include price over here. I know that these coffee beans cost $9 a pound. And I know these coffee beans cost $7 a pound. So I have an inequality. 9x plus 7y has to be less than or equal to $8.50. Well, I want to represent this graphically, and the easiest way to graph this is to find the x and y intercepts. So I'm going to create a table of values, x and y, and to find the y-intercept, the easiest thing to do is plug 0 in for x and solve for y. And what this would represent is if I bought all $7 coffee beans, how many pounds might I be able to afford? So I'm going to do that on my calculator here. And to solve for y, I'm going to take the price, $8.50, and divide by 7. And I get about 1.2. I'm going to round that. I'm going to round it to the nearest tenth. To find my x-intercept, I'm going to plug in 0 for y, and then solve how many $9 pounds I could get to be under that. So I'm going to take $8.50 divided by 9, and I'm going to get 0.944. I'm going to round to 0.9 just for ease. So I found my x and y intercepts, and I noticed that they're decimals. And I purposefully didn't put a scale on this because I wanted to find out what my results were here and hopefully help me make a better choice of a scale here. And notice another thing, we're looking at a real world example. We can't buy negative pounds of either of these types of coffee. So we're only working in quadrant 1 where everything's positive. So I look and things are decimals. I'm going to go up by 0.2s. So 0.2, 0.4, 0.6, 0.8, 1.0, 1.2. And I'm going to do the same thing along my y-axis. And let's see, my y-intercept is 1.2. My x-intercept is 0.9, which is going to be roughly there. And I have a less than or equal to. So I can draw a solid line between those 2 points. And since it's less than or equal to, I'm going to shade below that line. But above the x-axis and to the right of the y-axis, because everything needs to stay positive. And what that means is any point in here would represent a combination of $9 pound coffee and $7 pound coffee in amounts that would cost me less than $8.50. So for example, if I combined 0.4 pounds of the expensive coffee and 0.2 pounds of the less expensive coffee, the total cost of that coffee would be under $8.50. Additionally, any point that I picked that would be on the line would represent combinations of $9 pound coffee and $7 pound coffee that would add up to be exactly $8.50. So any point along the line would be where the total cost would be exactly $8.50. Any point I pick below this line but above the x-axis and to the right of the y-axis would be combinations of coffee that cost under $8.50.